So this lecture is the beginning of a short set of series on visualization and the principles of good design. So, what we're going to do, and you'll see me signpost it throughout it, is what I'm going to motivate why visualization is so important when we're thinking about data, give you some basic ideas about how to do presentations. Many times that's what people are going to see and remember about months of hard work that you've done with generating the data, so you want to put your best foot forward. And then kind of walk you through some principles of good design. What's good design mean in practice? What are the underlying ways in which we think about good design? And you're going to learn some technical terms like marks and channels. And then some ways in which you can make things pop out. And then once we've walked through the theory, you'll get a set of choices. Illustrative, there's an enormous amount of work that's been done in this area, so we're just going to skim over the basics so that I hope that you enjoy learning more when you're taking the class. So essentially, here's the issue. As you know, the college initiative is called Data, Data Everywhere. We have to stop and think. And the challenge is that when there's masses of data, what we need to be able to do is we need to be able to process it. That's why statistics in some extent were generated to start with. Summary information that we can process quickly that summarizes information about a distribution. So what visualization is doing, it's essentially the visual analog to statistics. It's providing a way of quickly summarizing the information and making a point and moving on. So visualization in some way is just another way of conveying knowledge. So, and our brains are pretty good at processing visual inputs. So if you take a look at the slide, you'll take a look at that string of numbers. Think how long it's going to take you to find the number 8 in there. Now take a look at another way of looking at it, and you'll see that the number 8 that has been highlighted in red jumps out at you. So clearly color is one way in which our brain processes information. What you'll see later on, and we'll talk about the marks and channels again, is that there are many different ways in which we can summarize that information in a way that makes sense. And kind of what this lecture is about is learning how to trim things down to the bare essence, so you're conveying what you want to know about the data, but you're not conveying too much. So there's an art to this as well as a science. So that's what we're going to go through. So those of you who read German will know all about the principles of Gestalt. So that's a fancy way of saying we're always looking for order and structure. In my marriage, for example, but otherwise, in trying to understand data. So how does our brain look for order and structure? Well, one thing is you group things with shared properties. So if you have worked with child development people and you look at Piaget would look at children and he'd give them a bunch of blocks. And kids will automatically start to group blocks. They might group them by color, or they might group them by size, or they might group them by function. All the cars together and all the trucks together, or all the fruit together in different types. But our brains we're pretty much hardwired to group things and aggregate things. So part of the way what you're doing with a visualization is presenting information that the brain is automatically going to group. That's the Gestalt thing that you can use at your next cocktail party. So, part of what we're going to be showing you is how to show the distribution of sets of numbers. So if you take a look at this slide, you'll see that on the left-hand side, there is a whole string of numbers, and you kind of look at that and you're trying to process it. Now in statistics, you might show the mean and the standard deviation, or the range and the minimum and the maximum, and all of that would be a very sensible way of presenting summary information. But if you look on the right-hand side, that box plot conveys the information much more quickly. It immediately shows you the median, the range, the minimum and the maximum, and it conveys some idea of the central tendency and the spread of the distribution visually. So there you see the direct analogy between visual information and statistics. So what's very, very cool about visualization is, we can all pore over numbers for a very long time, or sometimes we get deep insights from visualization. So the next picture is a classic picture. It's Jon Snow's cholera map, and it's of London in the early 19th century, I think 1830s. And what he did was 1854, I'm told. The challenge was that people were dying of cholera in London, and they had no idea what was causing it. And there were a lot of theories. Some people thought it was the miasma, it was the air, and it was kind of transmitted by the air that we breathe, or the fog, or the mists, and so on. And obviously people were quite worried. And so what Jon Snow did was he actually started to draw a map of where the deaths were occurring to try and figure out what was the relationship. Again, you see the analogy to statistics. You're trying to figure out the relationship between things. And when he drew the map, he found immediately what was going on. If you take a look at the density of the deaths, they're very closely correlated with the water pump. And that's how we found out that cholera was transmitted by water. And it's really one of the first times that we realized that diseases could be transmitted by water. And obviously that was an extremely important finding. Made a difference, for example, in the American Civil War. You'll read lots of examples about this. I won't go into too much detail, but if you look at Florence Nightingale and how she conveyed information about the impact of sanitation in field hospitals in the Crimea and the death rates, men were dying at a rate of 7 or 8 to 1 in field hospitals versus in the battlefield. And she conveyed that information very powerfully, visually, and effected change in the way in which treatment happened in hospitals. So there's lots of examples about how one or two powerful visuals really has an impact on decision making. And just to get the point of the power of visuals through one more time, there's this very famous 4 relationships. So this is called Anscombe's quartet. And if you look at those strings of numbers, the X and the Y, and take a look and try and figure out what the relationships are, it's not immediately obvious, right? You're kind of saying, well, what's going on with X and Y in these 4 different relationships? If you plot them and you see the visual, these are all generated by exactly the same, these all result in exactly the same regression. So if you were to run a regression of the Y and the X, and each one of those, you'd get exactly the same regression. But you'll see that the underlying data generating function, which is obviously what we're all about, trying to understand the process that generated the data that we're observing, the underlying data generating function is very different in the 4 data sets. So if the first thing that you did when you got a set of data was to run a regression, you'd miss a great deal. In the first data set, obviously, it's a pretty, you're capturing very much the relationship between Y and X. In the second data set, you're missing the quadratic relationship. In the third data set, your entire regression line is being pulled up by one outlier, so you'd want to go and find out what was going on with that outlier. In the fourth data set, it's pretty clear that there's no real relationship between Y and X, but there's one weird data point that is creating this potentially observed outcome. So that kind of summarizes the motivation, why I think you should be super excited about looking at visualization. what we'll do in the next module is talk about how you could take that motivation and use it to learn more about how to present data successfully.